Assalamualaikum and good day everyone. My name is Nurul Adriana binti Rudi Azhar, and today I will present the executive summary of our project entitled Optimizing Public Bus Services for Industrial Workers through an AI-based dynamic routing and shift synchronization system in Pasir Gudang. Let me begin with the background of our project. Pasir Gudang is one of Malaysia's largest continuous heavy industrial corridors, strategically located in eastern Johor Bahru along the Straits of Johor, anchored by Johor Port and Tanjung Langsat Port Terminal. The area is divided into two primary industrial zones tailored for heavy manufacturing, logistics and marine operations. With more than 300 factories with thousands of industrial workers commuting every day, however, Johor Bahru still does not have an LRT or MRT system, so many workers rely on private vehicles to travel to work. The current public bus system uses fixed routes and fixed schedule, which often do not match the different factory shift times. As a result, many workers experience long waiting times, overcrowded buses, and poor accessibility. According to reports, traffic congestion in Pasir Gudang is especially severe during morning peak hours, where an 11-kilometer journey can take up to 40 to 50 minutes, particularly on rainy days. These issues highlight the need for a smarter and more flexible public transport system. Because of these problems, several negative impacts can be observed. Firstly, heavy traffic congestion increases travel time for workers. Secondly, long waiting times and unreliable bus services reduce productivity because workers may arrive late at their workplaces. In addition, many workers choose to use private vehicles, leading to higher transportation costs, increased fuel consumption, and greater carbon emissions. To overcome these challenges, our project proposes an AI-based dynamic routing and shift synchronization system. The objectives of this project are to reduce travel time and workers' waiting time, to reduce traffic congestion, to increase public transport ridership, to reduce carbon emissions, and to reduce dependence on fossil fuels by encouraging greater use of public transport. Finally, our study focuses on Pasir Gudang Industrial Area, which is a home to many major manufacturing companies such as BASF Malaysia, Western Digital, Flex Malaysia, Malayan Flour Mills, Sintomer Malaysian, and Guangchong Cocoa manufacturer. This industry employs a large workforce, making a Pasir Gudang an ideal location to implement an AI-based dynamic bus routing system. That concludes the executive summary of our purpose project. Thank you for your attention. I will now hand over to the next presenter.
Hi, Assalamualaikum and good day everyone. Hi, I'm Fatin Nolena. In this session, I will present the literature review and benchmarking for our proposed project titled Optimizing Public Bus Services for Industrial Workers through an AI-based dynamic routing and shift synchronization system in Pasir Gudang. Based on the literature, one of the main challenges in industrial areas is that public bus services still rely on fixed routes and fixed schedules. According to CEDAR 2016, conventional public transport is designed based on predictable travel demand. However, this is less suitable for industrial workers because factories operate on rotating shift, causing the passenger demand to change throughout the day. So as a result, workers often experience long waiting time, poor accessibility, and also unreliable bus services, leading many to use private vehicles, which increase the traffic congestion and also pollution. To address these issues, many researchers recommend using artificial intelligence, which is AI, in public transport. Based on the systematic review by Idris, Kasim and Ramli 2026, AI can analyze real-time data such as passenger demand, GPS locations, and traffic conditions to recommend more efficiency, routes and schedules. Another important concept is dynamic routing. According to Westwagon et al. 2022, dynamic routing allows bus routes to be adjusted based on actual passenger demand instead of following fixed routes. This improves fleet utilization, reduces operational costs, and shortens passenger waiting time. Our proposal also applies shift synchronization based on Yuxalitis, CAT, and Liu 2021, aligning transport schedules with passenger demand improves service reliability and reduce waiting time. In our project, bus schedules are synchronized with factory shift changes to ensure workers can travel more efficiently. For benchmarking, we studied several countries that have successfully implemented smart public transport, which is we have Singapore, use real-time passenger data and GPS to improve bus services. South Korea applies AI to optimize bus dispatching. Shenzhen, China, use intelligent fleet management, and also Japan coordinate transport services with factory shift schedules in industry area. Although this system cannot be adopted exactly the same in Malaysia, they provide the valuable best practices that can be adapted for Pasir Gudang, especially in AI-based demand prediction, dynamic routing, and shift synchronization. So, in conclusion, the literature review and benchmarking show that integrating AI with dynamic routing and shift synchronization has a strong potential to improve the efficiency, accessibility, and reliability of public bus services for industry workers in Pasir Gudang. Thank you.
Hello everyone, my name is Siti Nuzahira binti Muhammad Taib, and in these sections, I will explain the proposed innovations and how the system operates to improve the public bus service for industry workers in Pasir Gudang. Identifying the transportation challenge is only the first step. The more important question is how public transport can be improved without completely replacing the existing system. Rather than introducing more bus or constructing a new infrastructure, this project focuses on improving how public bus service are planned and managed. The proposed solutions is to use artificial intelligence to support the operational decision making, allowing bus service to respond more effectively to the travel patterns of industrial workers. This concept is implemented through Shiftlink, an AI-powered industrial mobility management system. Instead of relying on fixed timetables, the system integrates factory shift schedules, passenger travel requests, historical ridership data, and real-time traffic conditions to generate operational recommendations that better reflect actual travel demand. So how does Shiftlink actually work? The system begins by collecting daily shift schedules from participating factories, while workers confirm their travel requirements through a mobile applications. At the same time, historical passenger data and live traffic information are continuously analyzed by the AI engines. Using these datasets, the system predicts passenger demands and recommends the most suitable departure times, service frequency, and fleet allocations. This allows public bus service to become more adaptive while maintaining existing routes and operational structure. One important aspect of Shiftlink is that artificial intelligence does not replace the transport operator. Instead, it functions as a decision support system. Every recommendation is generated by the AI, is reviewed and approved by the operator before implementations. This ensures that operational decisions remain under human supervision while benefiting from the data-driven insight, resulting in a transport system that is both efficient and reliable. By combining artificial intelligence with existing public transport infrastructure, Shiftlink is expected to reduce the passenger waiting time, improve the worker punctuality, optimize bus utilizations, and encourage a greater use of public transport among industrial workers. Ultimately, this innovation demonstrates how technology can transform conventional bus operations into a smarter, more responsive, and sustainable mobility system for Pasir Gudang. Thank you.
Hello, my name is Muhammad Arif Iqbal bin Khairil Anwar, and I will explain the operational feasibility of Shiftlink. Shiftlink is operationally feasible because it enhances the existing public bus operations in Pasir Gudang. Although Shiftlink improves operational efficiency, several implementation risks must be managed. The greatest operational risk is inaccurate factory shift information. Since the routing algorithm depends on real-time shift management, delay updates could reduce schedule reliability and passenger confidence. Another challenge is stakeholder coordination. Due to multiple factories and bus operators operate independently, successful implementation requires strong institutional collaboration and clear data sharing agreements. Operational disruptions such as traffic congestion, overtime production, or emergency shift changes may also reduce prediction accuracy. Finally, cybersecurity and cloud system failures should be addressed through encrypted databases, backup scheduling, and disaster recovery procedures. For the next part is the financial implication of Shiftlink. The project consists of capital expenditure or CAPEX and operating expenditure known as OPEX. CAPEX includes AI routing software development, GPS installation, cloud infrastructure, mobile application development, system integration, and staff training. OPEX includes cloud hosting, software maintenance, GPS communication, cybersecurity, and technical support. Although the initial investment is relatively high, the project generates long-term operational savings by reducing dead mileage, improving fleet utilization, and optimizing bus frequencies according to the actual passenger demand. Based on Prasarana Malaysia, efficient fleet management and data-driven schedule help improve service reliability while reducing unnecessary operational costs. Finally, I will discuss the project benefits and provide a critical analysis. Shiftlink directly addresses the transport challenges faced by industrial workers in Pasir Gudang, where conventional fixed bus schedules often fail to match changing factory shift patterns. Through dynamic routing and demand-responsive scheduling, buses are allocated according to actual worker demand, reducing waiting time, improving schedule reliability, and increasing public transport accessibility. Better fleet utilization also reduces overcrowding during peak shift changes while avoiding underutilized trips during off-peak periods. However, the project depends heavily on accurate factory shift data, continuous stakeholder collaboration, and sufficient financial investment. Overall, Shiftlink provides a practical and scalable solution for improving industrial worker mobility while creating a more efficient, reliable, and resilient public bus system in Pasir Gudang. Thank you.